Our moon's surface is covered with scars, left behind from the countless impacts throughout its life. Reminders that the early solar system was a very violent place. But amongst this pock-marked backdrop, one crater stands out. If you've ever looked closely at the full moon, you might recognize this Tycho Crater. Its long, wide rays stretch out like fingers over the lunar surface. This crater is 85 kilometers across, with the central mountain 2.5 kilometers high, and it was created by a cataclysmic event, one of such scale that not only was ejector catapulted to the opposite side of the moon, but its effects were felt all the way back here on Earth. But what collided with the moon to create this huge scar? When did it happen? And how did it impact life here on Earth? I'm Alex McColgan and you're watching Astrum. Join me as we head up to the lunar surface to learn all there is to know about our moon's incredible Tycho Crater, and to explore its greatest mysteries, many of which are still baffling scientists to this day. There are thousands of impact craters on the moon, 5,000 of which are more than 20 kilometers in width. But Tycho, named for the infamous 16th century Danish astronomer Tycho Brahe, is one of the most prominent. Formed by an enormous collision, more on that later, and stretching 85 kilometers in diameter, Tycho Crater is large enough to be visible from Earth with the unaided eye, particularly when the moon is full. From its rim to its floor, it is 4.8 kilometers deep. To give you a sense of scale, that's more than twice as deep as the Grand Canyon here on Earth. Bright rays emanate from its epicenter, reaching out thousands of kilometers. This curious splash pattern is what happens when a massive object impacts lunar soil, sending debris flying with enough force to wrap around the moon, all the way to its opposite side. Let's take a closer look at some of the features of Tycho Crater and see what they can teach us about its origins. After all, a crater of this size must have come from a pretty violent event. Perhaps the first thing you'll notice about Tycho Crater is its central mountain. Its peak reaches up 2.5 kilometers from the crater floor and stretches 15 kilometers across at its widest point. While much of the regolith that makes up the moon's surface looks similar to the untrained eye, NASA's Lunar Reconnaissance Orbiter discovered that the peak's surface is actually a treasure trove of interesting and distinctive textures. Some parts are smooth, others are blocky. The base is streaked with fine deposits, and there are enormous gullies. All these features paint a picture, and through this and other images, scientists have discovered that the rock that makes up Tycho's mountain is actually not the same kind of rock that forms the crater's basin or its rim. So, what's this out-of-place rock doing here? It's actually because Tycho is what's known as a complex crater. Unlike simple craters, whose impact basins are smaller and look like some giant has simply scooped out a chunk of the ground with an extra large spoon, complex craters are formed by impacts so large their collision creates recoil in the bedrock beneath the surface. Rock that was once buried deep gets propelled up in the center, forming peaks that are composed of a very different sort of rock to the rest of the crater. This process is a bit like what happens when a droplet of water lands in a pond. The surface is disturbed, water gets displaced, but then gravity reasserts itself, and the edges of the newly formed basin rush in to restore the equilibrium. All that inward rushing water meets in the middle, and with nowhere else to go, some is forced upwards. And when this happens to rock that has suddenly, violently melted, what was formerly bedrock is pulled up along for the ride. This is one of the reasons scientists want to study Tycho's peak further. It offers an excellent opportunity to learn what the deep interior of the moon is like. Surveyor 7 in 1968 discovered that the surface regolith in the area surrounding Tycho comprised basalt rock with high levels of calcium and low levels of sodium. But what lies deeper down? Until we sample the mountain itself, scientists can only guess how Tycho's bedrock fits into the broader geological narrative. Tycho Crater is visible from the Earth with the naked eye, but to truly appreciate its features you need the right gear. This is true of other aspects of the moon too. For instance, on the 12th of August 2026, the moon as a whole will be part of a jaw-dropping solar celestial convergence with our sun, a solar eclipse. And if you're in the path for that and want to see it, your eyes will thank you for choosing the right solar glasses, like the ones made by VisiSolar, the sponsor of today's video. When it comes to staring at the sun, even during an eclipse, using eclipse glasses that are not up to the right standards can leave you with serious eye damage, but not all glasses available online are trustworthy. Fortunately, VisiSolar's solar eclipse viewing kit is approved by the American Astronomical Society, meaning you can enjoy this incredible stellar phenomenon with complete ease of mind. I also like that VisiSolar's pack comes with a filter for your phone too, meaning you'll not just be able to see the eclipse, but can capture it in a way that'll last. The eclipse will be visible in Europe with partial coverage in America, so don't miss out, or you could be waiting years for another opportunity. Scan my QR code or follow the link in the description below. Viewers who use my code ASTRUM2026 at checkout will get 10% off their purchase. Now, back to Tycho Crater. There is another feature of Tycho's peak that tells us much about its history. Do you see this line running across the mountain here? This is a high watermark of a sort. But before you ask, no, this was not caused by an ancient lunar water lake lapping against the mountain, as cool as that would be. When the asteroid that impacted the moon created Tycho Crater and pulled that peak to the surface, the entire crater floor would have been superheated in the collision, into a boiling hot pond of impact melt. Under the softening influence of that heat and the insidious pull of gravity, parts of the surrounding rim would have later broken off and fallen into the pool, sending tsunami waves propagating out through the melt. This mark was formed when a tsunami of molten rock splashed against the peak's edges. Eventually the melt cooled and formed the surface we see today, though not without leaving these fascinating clues as to their past existence. Impact melt pooling also explains the smoother parts of the peak and the surrounding crater floor, but that melt can be found elsewhere. Let's widen our view to the surrounding landscape of the lunar surface. These breathtaking Hubble images of Tycho really showcase the violence that extended out beyond the crater itself. In 2013, Tim Kruger and his team of researchers at the Institute of Planetology presented a map of more than 3,000 melt pools in the surrounding area, highlighting where burning fragments of regolith would have been flung out across the moon's surface by the impact. By noting that there is one direction that had fewer melt points than the others, Kruger and his team were able to confirm that this hadn't been a direct blow, but the asteroid had likely come in at an oblique 35° to 45° angle, arriving from the southwest. But as I mentioned earlier, those balls of molten rock weren't limited to just the immediate area. The Apollo 17 mission landed at the Taurus-Littrow Valley in the Mons Taurus Mountains, a location 2,250 kilometers away from Tycho. One of the primary goals for the mission was to sample material taken from a landslide along one of the nearby crater walls. Specifically, they were targeting the light mantle, a prominent bright streak stretching 5 kilometers across the valley floor from the base of a 2-kilometer tall mountain known as South Massif. This site is the only known landslide of its kind on the moon, and is highly unusual even by lunar standards. It is a long run-out landslide, meaning the debris traveled an incredibly long distance across the moon to get there, and the exact mechanisms of this travel remained a mystery for decades. To solve this mystery, astronauts Gene Cernan and Harrison Schmidt, a trained geologist, successfully gathered samples from the site in 1972, bringing back a total of 110 kilograms of lunar material. Among these were 2 pristine core samples drilled straight out of the light mantle. At the time, officials at NASA knew that future technology would far surpass their own research capabilities, so they stored a portion of these samples away, completely untouched and sealed for over 5 decades. The time to unseal them came in 2025, when a team led by geologist Julia Magnarini from London's National History Museum used medical-grade micro-CT scans to peer inside these cores without damaging them. They analysed clasts, rocky fragments that broke off the slope of South Massive during the landslide, and compared their shape and composition to computer simulations of the event. And what they discovered is quite mind-blowing. As the mountainside began to collapse, the falling rocks started grinding against each other with intense force, eventually coating themselves in their own dust. This layer of fine powder lubricated the giant rocks, allowing huge masses of debris to glide across the lunar floor like fluids. This might finally explain how lunar landslides traveled so far. But another question still remained unanswered. What actually triggered this massive collapse in the first place? In more analyses of the Apollo 17 samples, scientists found traces of impact melt glass at the location. It is believed that these pieces of then super hot glass were thrown all the way from Tycho, and remember, that's more than 2,000 kilometers, causing the landslide when they crashed into the slopes of South Massive. This really gives you a sense of how far this glass flew. And no wonder, based on the size of Tycho Crater, the energy released from the impact that created it would have been comparable to 30 trillion tons of TNT, or 2 billion nuclear bombs on the scale of the one used on Hiroshima, all going off at the same time. This would create something far brighter than the small impact flash witnessed by Artemis II astronauts during their recent lunar trip. With a blast that size, some of Tycho's material would have not just flown around the moon, but escaped its weak gravity entirely. And where would they have gone after that? Well, towards the other large source of gravity in the immediate area, Earth. Imagine what this would have looked like for the dinosaurs alive back then. One night, the moon would suddenly flash with a brilliant light as the impactor crashed headlong into its surface. And for those ancient dinosaurs that missed the main event, there was still a show. The moon would have borne a strange, glowing orange scar for many nights to come, the signature of the red-hot impact melt still cooling on its surface. But as spectacular as that show would have been, it wasn't until hours or days later, once the debris had cleared the 380,000 kilometers between the moon and the Earth, that the real fireworks would have begun. Within hours of being jettisoned into space, most of the molten moon rock would have re-solidified into hard meteorites. Upon entry into Earth's atmosphere, that rock would start heating up again. 30% would have burned up entirely, lighting up the sky, but the remaining 70% would have hit the ground, bombarding the planet with tiny or larger fragments over the course of days to weeks. Enough material would fall that, if it were spread out, estimates from a lunar and planetary science conference predict it would have covered the entire Earth in a layer 0.1 to 0.3 millimeters thick. And of course, in reality, there would have been larger fragments here and there. But there is one mystery when it comes to this day of raining rock and glass. When exactly did it happen? And unfortunately, the answer is, we're actually not quite sure. When the Apollo astronauts brought their sample of glass back to Earth, cosmic ray exposure dating placed the Tycho Crater event at around 108 million years ago, right at the end of the early Cretaceous period. This makes Tycho Crater relatively young by lunar crater standards, and explains why the crater is still so pristine, and its rays are so bright. There's not been time for them to get disturbed by later, smaller meteor impacts. You'd think that locating small pieces of asteroid impact glass, known as tektites, at a similar point in the fossil record would have been easy. But in the whole world, there are actually only 5 known fields of tektites created by meteors, and none of them are related to Tycho. There is other evidence that is equally bizarre. In her doctoral thesis, researcher Elena Martin from the Lund University in Sweden demonstrated that Tycho could be older than 117 million years. She did this by searching for that Tycho meteor layer in sediment deposited on the floor in the Pacific Ocean, examining samples with ages ranging from 103 to 117 million years old. And yet, she found Tycho meteorites in precisely none of them. 1 grain was found that could have come from the moon, but it did not match the chemical composition expected from Tycho specifically. So it is still not clear exactly when the asteroid that impacted Tycho occurred. That's something only further study will be able to confirm. But while analysis of ancient impacts like Tycho is limited to samples and computer models, sometimes we do get to watch the moon get a brand new scar in real time. In late spring of 2024, a space rock traveling at extraordinary speed slammed into the lunar surface, punching a fresh crater 225 meters across, roughly the width of 2 football pitches end to end. Thanks to NASA's Lunar Reconnaissance Orbiter camera, scientists were able to capture the high-resolution before and after images of the site. It is the largest fresh crater ever observed during the orbiter's entire 17-year mission, more than 3 times the size of the previous record holder. It stretches 43 meters deep, features steep walls, and is surrounded by shattered boulders up to 13 meters wide. Deep inside, scientists even detected dark, glassy rock, flash melted by the intense energy of the collision. According to models, an impact of this scale on any given patch of lunar ground is a true once-in-a-century event, expected only once every 139 years. So catching it this soon after formation is an astounding feat of the LRO mission. While going to the moon seems like a rare and noteworthy thing, Tycho Crater demonstrates that exchange between the moon and the Earth happens more regularly than you might think. Across the eons, these 2 bodies have proven to be a dynamic system, where material from the one can sometimes, if conditions are right, find their way to the other. Astronauts are returning to the surface of the moon in 2028. Perhaps in time, once NASA has finished building its moon base, humanity will make their way to Tycho Crater itself, and through careful study of its slopes or by climbing its peak, will answer once and for all the numerous questions about Tycho's origins. Until then, if we want to learn more about Tycho Crater, there is always that layer of rock and tektites to find. We don't need to go to the moon, we have Tycho Crater at home. The Astrum newsletter is one of the most beautiful reads you'll ever get. Even if you're not in it for the news, our photo of the week always makes it worth opening. Sign up with the link below. It's a quick, inspiring way to stay connected to everything happening in the cosmos, from discoveries to missions and the stories behind them. Each issue is carefully designed and written to make science feel exciting and easy to follow. If you already enjoy our videos, you'll love having this in your inbox every week. Join thousands of readers exploring space with Astrum.